fifth graders. Happy weekend. Oh, don't forget the beep beep. Can you say hi, guys?
Hi, guys.
Hi, guys. I hope you guys are having an awesome weekend.
Boo Patriots.
We're feeling a little better in our house about that Chicago Patriots game. We're going to get into lesson 5, you guys. We're working closer to the standard algorithm when we're multiplying two two-digit numbers together. We're moving towards the standard algorithm today. We're not completely in the standard algorithm. We're going to be doing some modeling alongside the standard algorithm so we can really connect.
All there.
Yes, all fall down. So we can really connect those two and we can have a deeper understanding of what the standard algorithm means. So let's take a look at a couple of models here. You say, have a great week, Cal. Cal, you say, have a great week.
I read the week.
Cal, what are you going to be for Halloween?
Out.
What are you going to be for Halloween? He's gonna be scary dinosaur. Okay, guys, let's take a look at some examples here. Here we go, guys. Oops. We are in lesson 5. I am completing this video on the 21st, but let's just go ahead and put 1022 in our notes because we are going to be practicing lesson 5 on 1022. We, like I said, are going to be working towards just the standard algorithm for multiplication, but before we just jump right into this, or belly flop right into this, we're going to connect the multiplication with area models. So here in this first part, we're asked to draw an area model and then solve using the standard algorithm over here, and use arrows to match the partial products from the area model to the partial products of the algorithm. So I'm so excited about this lesson, you guys. It's just, I just consider us to be very lucky to have the opportunity to spend some very thoughtful time working on having a deeper understanding of these mathematical processes because, and you can go ask your parents this, I'm just going to clean this back up. Back in the day when I was a 5th grader, we just went straight to this and we never did any sort of work to understand why this algorithm works. So that's exactly what we're going to do here. So I'm going to label this top part with 34, and then I'm actually going to decompose 21 into 1 and 20 because I can essentially do these calculations in my head. So the first expression that we're going to see in this, hi buddy, hi sweetie, oh thanks for that hug. Cal's coming in to give me a math hug. So the expression I'm going to find in this part of our area model is 34 times 1. Okay, cool. And then in the second part, in this larger part, we're going to look at 34 times 20. Okay. So we have 2 expressions which are going to result in 2 partial products. So the reason why I broke 21 up into 20 and 1 is because we can absolutely multiply 34 by 1 in our head. One copy of 34 is indeed 34. Now let's go ahead and do 34 times 20 in our head. 34 times 2 is just, we can just think about adding 2 34s. I think we can do that. A lot of us can do this in our head. 34 times 2 is 68, but this actually isn't a 2, it's a 20. So we're going to bring along 1 0. Do you guys know all of that work we've been doing in lessons 1 through 5 on mental strategies for multiplication? Here's why. We've been practicing that, and that work is going to support this lesson and the lessons moving forward in a really wonderful way. Okay, so now I have 2 partial products. A product, keep in mind you guys, is a fancy name for the answer to a multiplication expression. These are not the full products, these are just partial products. We have one part of the product here and one part of the product here. Let's go ahead and connect these to our traditional algorithm over here. And I'm going to use Chicago Bears colors, even though we lost. We were so close for you, those of you that were watching that final play. Okay, so let's look at 1 times 4. 1 times 4 is 4. And then we're going to look at 1 times 3. 1 times 3 is 3. So this is a partial product. Now we're going to go over and see if these two numbers match. Yes, we are all good. Okay, now let's go ahead and do our second line. So here we're going to multiply the 2 into the 4 and the 3. But this, you guys, is not a 2, it's actually a 20, remember? It's not a 2, it's a 20. So let's think about that and think about what is 2 times 4. Well, 2 times 4 is 8, but you guys, that is not a 2, it's a 20. So 20 times 40 is 80. Keep in mind, you guys, whenever we go to the second step for our second partial product, this too is in the tens place value. So you have to remember that because whichever digit is going to be here, it's in the tens place value, the product or this part of the product is going to end in a 0. The old school rule is that we just mindlessly put a 0 here and then we multiply through. But we are not mindless math zombies. You guys, I need you to be very thoughtful when you're doing this multiplication to remember that we're looking at a 20 times 4. Yes, 20 times 4 is 8. And now we're looking at 20 times 3, which is 6. 2 times 3 is 6. 20 times 3 is 600. That's why the 6 is in the hundredths place value. So let's go, oh great. So that also matches with our partial product from our area model. We are in good shape. The final step will be to add up our two partial products. I didn't do a great job of lining up my place values, but let's just do our best here. So let's look at 4 plus 0, which is 4. 3 plus 8 is 11. We're going to carry that over, and we're looking at a final product of 714. Let's see if that's what we end up with over here in our standard algorithm. 4 plus 0 is 4. 3 plus 8 is 11. Great! We have 714 here and here. Very cool, huh guys? Let's get another area model with our standard algorithm matching up. Let's take a look at this one. We are going to be doing the same thing as far as drawing an area model, solve using the standard algorithm over here, and then connecting the partial products along the way. These numbers are very similar to what we saw in the previous expression. Keep in mind, you guys, when we're doing something new, we start with very basic numbers. We start with very simplified numbers, and then as we continue working on our area model and our standard algorithm, the numbers, of course, will become more and more complicated. So we are just starting off with very friendly numbers today. Okay, so we're looking at 24 times 21. As you can see, I'm still working on drawing really nice rectangles. I'm not quite there yet. We're going to draw an area model here, and I'm going to label the width from here to here with a 24. And then I'm going to decompose 21 into a 1 and a 20, just like in our previous problem. And the reason why we're doing that is so that we can multiply these numbers mentally. Okay, so the expression that's going to go inside this box is going to be 1 times 24. Would it be okay to write 24 times 1, Violet? Yes. I'm receiving a mental response from Violet. Yes. 1 times 24 and 24 times 1? Absolutely fine either way. If we were adding 1 plus 24, we can write it like this. Or we can write 24 plus 1 like this. What if it was, this is fine, this is fine. What if it was division? Can we do 1 divided by 24 or 24 divided by 1? No way. That is not okay. We cannot flip those. What about subtraction? Is 1 minus 24 the same as 24 minus 1? No, friend. Absolutely not. Multiplication, addition, fine. Division, subtraction, you cannot flip your numbers. Okay, that was fun. Now let's look at the expression inside this this is not a triangle with colors, this is a rectangle. We are going to look at 20 times 24. Okay, so let's find our 1, 2 partial products. Well, 1 times 24 is 24. 20 times 24, let's think about 2 times 24. Well, I know 2 times 24 is 48, but that is not a 2, it's a 20. So we need to bring along 1 0 to the party. So we have 2 partial products, 24 and 480. Cal's mimicking me. Let's go ahead and connect. Let's go ahead and connect this area model to our standard algorithm. So first we're looking, we're looking at 24 times 21. First we're going to look at our 1 times 4, which is 4. And then we look at our 1 times 2, which is 24. Is this number the same as this number? Check. Beautiful. And I know that I made this a little busy, but that partial product matches with this first expression in our area model. Now we're going to go to our second level and we're going to multiply our 20 into our 24. What is 20 times 4? Well, 20 times 4, thank you very much, Dylan, is 80. Keep in mind, you guys, this is not a 2, it's a 20. Look at the place value. That's why the resulting product is 80 and not just an 8. Now let's look at 20 times 2. 20 times 2 is 400. That's why this 4 is in the hundreds place value. Let's see if this number matches with this number. Woohoo! We are on a roll. So now we have 2 partial products. Good news is that our area model partial product matched up beautifully with our standard algorithm partial product on the first row and the second row. So that's good news. What we're left to do here is add up our partial products, and I have to be much more thoughtful with my alignment over here because as you guys can see, my lanes are a little wobbly. So let's make sure when we're adding our ones place value together. So we're looking at 4 plus 0, which is 4. We have to add these 2 partial products together in order to find the final product. So we have 4 plus 0 is 4, and we have 2 plus 8 is 10. Bring over a 1, and we're looking at 1 plus 4, which is 5. Let's see if we get the same final product over here with our standard algorithm when I add together my 2 partial products. So we have 4 plus 0 is 4. 2 plus 8, thank you, Grayson, is 10. And then Katie, 1 plus 4, 5. Same number here and here. Yes, it all worked out. Fabulous, fabulous. The secret word, you guys, is I'm stuck. Secret word is I'm stuck because right now Cal is saying I'm stuck. I can't wait to see you guys tomorrow. I can't wait for another wonderful week. Oh man. Secret word is I'm stuck. I hope you guys enjoy the rest of your afternoon, and I'll see you guys tomorrow.